have seen how to process DFA. How to process the strings by DFA we have seen already. In today's session we will see language is given. For that language, how to construct the DFA for that. We will see today's session then. So I said about construction of DFA, which means nothing but construction of minimal DFA. What minimal DFA means? DFA which consists of less number of strings. So that we call it as minimal DFA. In every problem, like construction of DFA is nothing but construction of minimal DFA only. Okay. So now we will see with an example. So here construction of minimal DFA only, but I took three different problems. So first one, let us say this particular one. So and all the three problems are over an alphabet A B only. Small a comma B are the input symbols. Now here strings started with A comma B. So for this strings started with A comma B, we will construct three DFAs parallelly. Strings started with AB, substring AB, ended with AB. We will see three different problems. First one is this one. Strings started with AB. For any problem, first you need to write the language. So here I am writing the language, what my language means. L is equal to. Here L is what? Strings started with AB. So strings started with AB, therefore my first string in this language is AB only. Then the next one is A. So because AB must be included because started with AB. In all strings are started with AB only. So that's the reason ABA. Then my next string is ABB. And then my next string is ABAA. And so on so forth. You will get many more. So now after writing the language, you need to check whether that language is finite or infinite. So this is the common procedure for any DFA. First you need to write the language and you need to check whether the language is finite or infinite. If it is finite, you need to take the greatest length string. For that greatest length string, you need to draw the skeleton. If the language is infinite, you need to take the least length string and draw the skeleton of the DFA. What it means, let us see here. So here, this language is infinite, right? So definitely it is infinite. Many strings are available in this language. So it is infinite. Since it is infinite, so we need to take the least length string. So least length string is what? AB is my least length string. For that least length string, we need to draw the skeleton. What skeleton means? Let us see here. So here, DFA starts with, so what is my least length string? Here I am writing once again, least length string. Least length string is AB, right? So for AB, I need to draw the skeleton. So skeleton means, so here started with the state A, and then, so what is my first input symbol? A, and then the next state B, and then the next state, this must be final state. Why? Because I need to accept, right? So here A, here it is B. So finally I am accepting. So because AB, my string is available in this language. Therefore, for this AB, this is the skeleton of the DFA. This is the skeleton. For every problem, you need to draw the skeleton first, and then after that you need to work on the DFA. So here, so this is the skeleton of the DFA, and after that you need to check here. So now we need to check whether the states are complete or not. What states are complete means. So here if you look at here, this is the starting state, and for this state, so there are two input symbols are there, A and B. If it is A, we have a transition, but if we are in the state A and if we have the input symbol B, no transitions are available. So that's the reason this state is not complete. So that is the meaning of complete. Similarly, if you look at here C, the state C is complete? No, because we don't have transitions when we are in the state C, and if you are having input symbol small a or small b, you don't have transitions here. So that's the reason this state is also not complete. Similarly, B also not complete. Why it is not complete? For the state B, so we have the transition with the input symbol B, but we don't have the transition with the input symbol A. Therefore, the state is also not complete. So first, after draw the skeleton, then you need to check first state whether it is complete or not. It is not complete. I told you what complete means. So this is not complete. So first try to convert it into complete. So for that, how to do it? So first you try for the self loop. Possibility you need to check. Try give a transition with the self loop. If possibility is it is there, if it is there, you can find out, you can complete it. And if the self loop is not possible, then give a new transition with the available states. And if it also not possible, then form a new state. This is the steps one by one. So here first I need to check. So here the state is not complete with the input symbol small b. So if I give an input symbol small b, is there any problem occurs? You need to check. If you give a self loop here with the input symbol b, then what the problem is? So here if you look at here, if you have a self loop with b, then strings also may start with self loop, therefore you will get a b first. But here my string started with what? A. So strings started with A. So if you give a self loop here, strings also may start with B also. But that kind of strings are not available in my language. Therefore, if you give a self loop, you have a problem. So that's the reason don't give it. Then, as I said, move on to the next step. What is the next step? Try to give a transition with the available states. For example, if I give a transition like this, so if I give a transition like here, like if I give a transition like this, again a problem. What problem? So here, if you have a transition like this, then B you are accepting, but my B string is not available in my language. Therefore, I cannot give this transition here. Similarly, so first self loop I cross check, not possible. Then with this state I check, and then I need to check this state also. If I give a transition like this, is there any problem or not? If you give a transition like this, then you have a B, we have a string B which is you are accepting. So straight away B is the symbol only B, then you are accepting because from starting state to final state case. But my string B is not available in my language. Not available in my language. Therefore, I cannot give this self loop. I cannot give this self loop. So as I said, self loop not possible, and the transition, new transition with the available states also not possible. Therefore, what I need to do? Move to the next step. What is the next step? Form a new state. So here I am forming a new state. Let us name it D, and here it is B. Why I formed the state? I cross-checked the self loop option and then transition with the available state. So those are all not possible. That's the reason I given a new state. Dial one more new state and given a transition with B input symbol. Then now look at the state. The state is complete now. Because for this state A, whatever two input symbols are there, those two input symbols are available here. So therefore the state is complete. Then move on to the next step. So now, is this state is complete? No, it is not complete, because for this state B, if you have an input symbol small a, so we don't have a transition. So therefore, so now let us start with the same logic what we applied. So here, try to give a self loop here. If I give a self loop, is there any problem or not? You need to check. So here, if I give a self loop here, then the problem occurs is a, then followed by any number of a's and then b. But here, strings must and should start with AB only. But if you give a self loop here, the problem is AB are getting, but one more chance is AB are also AB. So because of the self loop, my string is what? AB or AB and so on. But if you look at these strings are not available in the language. Because A, but first symbol is A and second symbol must be B only. But here those are not there. So therefore, that's the problem. That's the reason you cannot give a self loop here. You cannot give a self loop here. So now try with the other options, like giving the self loop like here. If you give a self loop like this with A, then you are accepting A. So here if you give a self loop like this, A and followed by A you are accepting, but A is not available in my language. Therefore, no possibility to give here. Let us move on to back. So if you give a transition like this, is there any problem or not? You need to check. If you give a self transition like this, then the problem is A. Then you are getting A. So and you will get A, and finally you will get B. But my language doesn't consist this kind of strings. Therefore, definitely I cannot give this transition. And I cross-checked with the available states. These states are completed. One more state here it is there. If I give a here, is there any problem or not? If you give here, I think no, there is no problem. Okay. So like so on, you need to continue the same procedure what I said. You need to apply each state is complete or not. You need to check, and after that you need to do the procedure what we discussed right now. So now the state is complete now. The state is complete. Let us move to this state. This state is complete or not? Not complete, because for this state you don't have any transition with the input symbols A and B. Therefore, first I need to convert this state also complete. Now, here when we reach to here, what it means? You seen a and then you seen a small b. That means you reached whatever the condition like AB. We got that string AB started with AB. After that, I don't bother whatever it may be, whether it is A or whether it is B or any number of A's or any number of B's, we don't have any problem. So that's the reason. So as I said, it is not complete. So let us try to give a self loop here. So here I am giving a self loop with the symbol small a and similarly small b also. I am giving both the symbols. The reason is after AB I don't care whatever it is. It may be any number of A's or any number of B's. So if you give a self loop here, there is no problem for us. That's the reason I given the self loop. So now the state is complete. Now the remaining, the state is complete, this state is complete, this state is also complete. Now let us check this particular one. This state is not complete, right? So because here we don't have the transitions. So same way, so try to give a self loop here, give a self loop A comma B. Then is there any problem or not? You check. I think there is no problem. So that's the reason you can give it. So why no problem? As we seen some of the examples already. That's the reason. If I explain one more time, the same thing will replicated one more time. So this is the final DFA. So now this is the final DFA. Now I need to check, take a string which is available in the language and try to test whether this DFA is accepting or not, and try to take a string which is not available in the language and try to check whether this DFA is rejecting or not. You need to check both. So for that I already given examples in the last session. So now let us take an example. So here I am taking A, B, A. I am taking this string. So as I said, I am following the second method in the last session. So here I need to start with the starting symbol A. So then A. So A I am getting B. B. So B it is C. C only. C only. So what you check, is that final state or not? Yes, it's final state. What is the string here? I will put the string what? A. So this is available in my language and DFA. Finally you are getting a final state. That means you should accept this. Now I am taking a string which is not available in the language. I am taking A. So now this language is not available. Just look at there. So because my strings always start with AB only, but here it is start with AA. So it is not at all available. Now try to check it here. So write the same pattern A. Now string started with A. Again AA means what? B. BA means D. DB D and DB D. Finally you got a state D which is not final. Therefore definitely DFA should reject this. Okay, so in the same fashion, so we need to continue those problems also. And one more important thing here it is, in the when we are reaches to this state, you cannot go further. So that's the reason this kind of state we call it as dead state. This kind of states we call it as dead state in any DFA. So why? Because if you move on to D state, from this state you cannot move on to any other state. A, B, C you cannot move. So you can. So this is the final state. The final means end state, dead state. So that's the reason. So from this state you cannot reach to any other state. That's the reason this state is called as dead state. Okay. So now this is what string started with AB. So in the same fashion, you can do many more problems. String started with 0, 1 or ABA or AAB. All those problems in this fashion. Let us move on to the next one. String. Now it is what? Construction of the DFA where the string consists a substring AB. Now let us write the language. L is equal to what? So language again AB is there because in a substring. Substring means in my entire string AB must be there somewhere. So here it is in the beginning only, but now it is AB anywhere. Okay, so that's the reason AB is there. And then here I am writing here AAB, yes, it is also there. And similarly BAB, it is also there. And then here AAB, yes, AABB, and so on. So now look at this language. Once again, this language is infinite. So this language is what? Infinite. So for infinite, what we said? If the language is infinite, you need to take the least length string and try to draw a skeleton. What is the least length string? Again AB. So for the AB, we know already how to construct the skeleton for AB. So I am drawing the skeleton A, and then here B, and then B. Here it is C. It's my final state. So this is the skeleton. Now I need to once again the same procedure, like whether the states are complete or not, I need to check, and the same procedure. So let us move on to first I draw the skeleton. I need to check whether the states are complete or not. If it is not complete, try to convert into complete. So now here substring AB. So now here we are now here. So now if we are in the state A, so if the state is not complete, the reason is input symbol B, we don't have a transition here. So let us try to give a transition. If we give a self loop, is there any problem or not? You need to check. If we give a self loop, what happens? Before AB, we will get some number of B's. Any number of B's, no problem. Is there any problem? No. Why? So because after any number of B's, here whatever substring we require, that is not disturbing. So here AB is there in front. Prior to AB, you are getting any number of B's. Sorry, any number of B's. We don't have any problem there. So because my substring is AB is there, that is already there, no problem at all. So therefore, you can give a self loop here. There is no problem. Now, if you look at here, the state is complete, right? So the state is complete. Let us move on to the next state. So now this state is not complete. Why? We have a transition B, but we don't have the transition A. So now for that, what I can do? So here, if we give a self loop here, is there any problem or not? You need to check. If we give a self loop here A, then what I am getting? A, then I am getting B. So is there any problem or not? So here you are getting some number of B's, and after that you are getting A, and then so yeah, because of the self loop you will get many number of A's, and then you are getting a B. So now look at my string consists AB. So string consists AB. That's here the topic is substring consists of AB. Wherever it is, we don't have any problem. So here substring consists of AB. There is no problem. That's the reason you can give the self loop here. There is no problem. So now the state is also complete. Now let us move on to the next state. This state is not complete. So the state is not complete. Why? The reason is transitions are not available for the input symbols AB. Therefore, the state is not complete. Now, after getting AB, that means we are getting a substring AB. After that, we don't have any problem. So that's the reason you can give a self loop here with the transitions A. With the transitions AB. Therefore, so this is the final answer. Now all the states are complete. I am getting my answer. This is my minimal DFA. So we got with the 3 states only we got. That's the reason we are setting minimal DFA, right? So now let us take a string which is available in the language. So now I am taking the string A, B, A. I am taking the string. So the string is available already. So now to process that, I need to write some gap between the symbols. So let us start with the input symbol A. I am moving to B. Then B, A, I am getting B. So B only. B, I am reaching to C. C, A, so I am reaching to C. What state I got? Final state, which is final state. So final state, therefore I should accept this. Now I am taking one more string which is not available in that. So I am taking B, A. Now let us take this particular string. This string is not available in my language. So now to process that, use the second method B, A. So started with A, B I am getting A, I am getting B, A again getting B, A then B. So now let us look at this which is not final, non-final state. This is not a final state, right? Not a final state. Therefore, what I need to do? I should reject. That means DFA, reject this automata. So always for construct the minimal DFA, you need to construct the DFA and take a string which is available in the language and verify whether the DFA is accepting or not. In the same fashion, take a string which is not available in the language and verify whether the DFA is rejecting or not. You need to do both. Okay. So let us move on to the last one. End with AB. So now end with AB. Now write a language, end with AB, again you will get AB, then AAB. So that means all the strings are ended with AB. Just while writing the language only you can easily identify what it is. And so on. There are many infinite language, again infinite strings are there. So now look at here. Strings ended with AB. So here while writing the language, substring AB, somewhere AB must be there. So this is substring. Here it is started with AB. All the strings started must be AB only. but here it is strings end with AB. So all the strings ended with AB only. So now this is once again check it whether the language is finite or infinite. Again it is infinite. So for infinite, what I need to do? Take the least length string. What is the least length string? AB is the least length string. Take that and draw the skeleton. I think we know. I think 2 times we draw the skeleton for AB. That's the reason I am continuing and completing the skeleton. A and then B and then here B. So this is the final string. So this is the skeleton. So now after skeleton, once again I need to check states are complete or not. So now let us here check it whether the state is complete, the state is not complete, we know it already. So the state is not complete. So now if you give a self loop, is there any problem or not, you need to check. If you give a self loop here, is there any problem? Ending must be AB, after that we don't bother. So that's the reason there is no problem to give the self loop here. So therefore the state is complete. Now let us move on to the state. This state is not complete. Again check it. So here, can you give a self loop here? If you give a self loop, so after any number of years, A you are getting, after that you are getting a B. That means ending is AB only, no doubt. So no problem. That's the reason you can give the self loop here also. So now the state is also complete. Let us move on to this state. This state is not complete. Ending must be AB, right? So here this state is not complete. You need to give a transition. So now ending AB. So here it is AB. The state is not complete. So for that, so here, if you give a self loop, is there any problem or not? You check it. So if you give a self loop here, A, B, after that if you are giving A, if you draw a self loop A, B, is there any problem or not? We need to check. So here, if you give a self loop here, the problem is after AB, ending AB already, then you are getting A. So now look at here, A, B. If you reach to here, some B's are there. Let us say some B's are there. Then after A, and then you are getting, since because of self loop, you are getting some A's, and then you are getting this B. Then, because of this self loop, if you have a symbol A, then the ending is, let us look at now, BA is the ending. So if you give a self loop with the transition A, you are getting a problem. Similarly, instead of A, if you give B, again that is the problem. Because what? If you give a B, ending is what? BB. But what we require? AB. So you cannot give the self loop here. So now let us move on. Let us give a transition with the available states. Now, if we give a self loop, if we give a transition with A, is there any problem or not? Let us check. So if you give a transition here like this, then some B's, then you are getting A, then because of the self loop you are getting some A's, and then you are getting B, then you are moving to the state A. So let us write here, some B's are there, then you are getting A, and some because of self loop some A's you are getting, and then you are getting B, and then so from C to, because of this transition you are getting A, then after that if you get a self loop or not get a self loop, you may get some A's, or if you are having self loop, you will get some A's, otherwise you will get only A, then you are getting B. That means ending is B. There is no problem, right? Therefore, you can give a transition like this. So now this state is not complete because we need one more transition with input symbol B. So let us give it to here. But if you give here again with B, you will get a problem. The reason is BB you will get. Ending is to BB. Therefore, you cannot give there. So here now you can give. So now you can give like this. Then there is no problem. So this is the final minimal DFA for the strings ended with AB. So now let us take a string. So let us I am taking AB. Now look at my ending is AB, right? So now let us check whether it is accepting by automata or not. So let us start with the initial state. A I am reaching to B. B I am reaching to C. C I am reaching to B. And then B then reaching to C. Now check it here, which is a final state. So that means I need to accept this. That means the DFA accept that. Then move on to the next one. Let us take one more. A, B, B, B. So this is my next one. This is not available in my language. So once again, with the second notation A, B, B, right? Starting with the initial state A. Then if we start A, then I am getting B, 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 I am getting C, C, D, I am getting A, B, I am getting A. So now you guess which is a not final state. Not final state. This is not a final state. Not final state. So therefore, I should DFA should reject that one. Okay. So this is the DFA where the strings end with AB. So now, this is one of even in the GATE examination you may get a question like this. Strings started with AB, substring AB. How many states are there to your minimal DFA? So now if you look at here, this is the substring. That means substring of length how much? 2. If so here substring of length n. Substring of length n. Then the number of states in minimal DFA is n plus 2. Similarly, yes, substring of length n, same. Substring means AB length. So here you will get n plus 1, and here you will get n plus 1. What it is? So that means what the minimal states, the minimal DFA, where the string started with a substring of length n. Started with a substring of length n, then my number of states in the minimal DFA is n plus 2. The same fashion. So the number of states in the minimal DFA where the language consists a substring of length n, then the number of states are n plus 1 only for a substring. Then here it is the substring end with a substring of length n, then it is also number of states are n plus 1. Okay, so that's the session for today. We'll continue the next session.